Hi, and welcome to another episode of my KTM Duke 250. In this episode, I will try to fix back the fuel tank float where I had posted a video last year pertaining to my dysfunctional fuel gauge on my KTM Duke 250. And the root cause for the malfunction is because of this fuel tank float located inside the fuel tank. It's coming off on itself from the connecting rod on the fuel pump inside the fuel tank. I've been riding this bike without any fuel gauge indicator for around almost 1 year, and there is one time I'm completely running out of fuel when I'm riding my bike on my way to work, maybe due to my mistake on a distance calculation between every refill interval. Now, I will be stopping to refill my bike once I'm hitting a 300 kilometer mileage from the last refill. So without further ado, let's open up the fuel tank cover. Okay, so in order to take off this fuel tank cover, I need to remove the rider seat and also a lot of screw. This screw in front here, this Allen key screw holding the fuel filler cap, fuel head screw here, hexagon nut beside here, which is also act as a hook to the rider seat, and also this screw. There are two screws here on this panel below the rider seat, as this one and the panel here are interlocking each other on this side. And also last, the coolant cap in front here. Okay, so every screw has been removed. I can now totally take off the fuel tank cover. This hose to drain out excess fuel when you overfill the fuel tank. This is what basically it looks like inside the fuel tank cover. Okay, next step, I had removed 4 screws holding the ECU to the fuel tank, and then these 2 screws, the final 2 screws, positioning the fuel tank to the chassis. It's quite tight here. Okay, I will not remove this, what appears to be written here, cup cap mounting, to prevent spillage all over the fuel tank if overfilled. Okay, this dangling like this, and this is the fuel tank. This is the fuel tank that I had removed, and I can feel that inside still have around 4 liters of fuel and currently weight around 7 kilograms or 14 to 15 pounds. And underneath this fuel tank, I can find this is the fuel pump unit, and this is the fuel filter. I also have disconnected this fuel line hose that delivers fuels from the fuel filter into the fuel injector here. This is the fuel injector, and this is the engine head, this is the breather hose, and I also had disconnected this connector that supply current to the fuel pump inside the fuel tank. And since I had wasted my time and effort to open up the fuel tank, so why not? I just do a little bit extra to change the old fuel filter to this new fuel filter. This is the original OEM KTM engine part. I bought it from the authorized KTM bike dealer, and here it says fine fuel filter, original part made in India. And inside it looks quite a bit different from the normal fuel filter that I've seen. This is the car fuel filter, which have only 2 openings. This one sending in a dirty fuel, filter out, sending out a clean fuel into the fuel injector. But the KTM have 3 openings. This one go in, here go out, and this one will send back excess fuel into the fuel tank. This is because the fuel pump will just keep on pumping fuel. It will generate pressure, but let's say if it generates over pressure, then it might worry to break up all the components in the fuel feed system. So this one will send back the excess fuel into the fuel tank if the fuel injector didn't release the amount of fuel into the engine. So this is basically how the electronic fuel injection system works on the KTM Duke 250. And today is a brand new day, and before I'm going to take out the fuel pump to repair the float inside, I would like to have some fun with it. I would like to know how much pressure that the fuel pump can generate, and so this is something that I created. This is a hose. One of the end I've joined it to the filter outlet. In the middle part here I have this pressure gauge, and one of the end I've joined this needle. This needle is used to inflate a basketball. I would like it to act as a nozzle of a fuel injector. And here I've joined two wires into either two of the 4 pins of this connector and hook it up to my car battery. I've never done this before. I don't know how much pressure that this fuel pump can generate, and I really don't know what will happen later, so let's see. Okay, first test, I will clamp almost the near end of the nozzle and see how much pressure that it can generate. Okay, in 3, 2, 1, go. Too high pressure, too high. Yeah. Yes, that is possible. It generates almost a 30 bar, 31 or 32 bar. Like this. Okay, 1, 2, 3. It generates more than 50 bar. Wow, 50 bar. Oh, this is a very high pressure fuel pump. 50 bar on the close loop. Wow, very incredible. Okay, second test. I will let this nozzle dispense out the fuel and see how much pressure that this can generate. 1, 2, 3. Ooh, 30 bar. 30 bar. Wow. Oh, 30 bar, and through this have an opening of about 2 millimeter here inside, and it should fill about up to the front, about more than 10 meters into the front. Okay, final test. I've opened up the nozzle, and I would like to know how much quantity of fuel the fuel pump can deliver. Okay, so I have this measuring jug here, and I have my stopwatch here. Okay, so in 3, 2, 1, go. Okay, stop. So it can fill up 500 millimeter of fuel in just about 12 to 13 minutes. So in a minute, 12 to 13 seconds. So in a minute, I think it can dispense up to 2.2 or 2.3 liters. Before I proceed to remove the fuel pump from the fuel tank, of course I short and completely drain out all the remaining fuel inside this fuel tank. And currently this container contains about 3 liters of fuel, while the fuel tank now is currently empty. Okay, no fuel in it. According to the flow rate that I measured just now, if the fuel tank is full, the fuel pump unit will be able to empty all the 11 liters of fuel in it in just 5 minutes. But of course with zero resistance. And the story will be a lot different if the fuel will be delivered through the nozzle on the fuel injector. This is because the nozzle on the fuel injector have a very fine hole to produce mist to mix with the air in the intake to let the engine burn more efficiently. So next I shall proceed to take off the fuel pump from the fuel tank. So this is the fuel pump unit, and it comprises of 4 main components. The first is this is the fuel pump, which is so obvious. And the second is this appears to be some kind of a filter used to filter out all those debris and small little particles inside the fuel tank. The purpose of this is to prevent the foreign materials to be sucked into and further protecting the fuel pump. The third is this, where I assume this to be the mechanical fuel pressure regulator, and it has a spring in it to control the pressure in the fuel lines. I hope this is visible inside the video. Okay, this is because the fuel pump does not control pressure that it generates, and if, let's say, it did generate overpressure, for example 55 psi, then the pressure in the fuel feed system is higher than the pressure of this spring can withstand. And then the fuel will push open some valve and burst out excess fuel back into the fuel tank. The fourth is this is the float sensor. Here is a PCB with some contact terminal, and inside here I see there is a tube plate used to conduct current to sense the level of the float inside the fuel tank like this. Okay, this is about full. This is almost empty, and this is the float where I repaired just now and reinforced it with some plastic washer. Okay, and I had cleaned up the whole unit just now and exchanged the fuel filter, and I can say the fuel filter is extremely dirty. Let me show you guys. See all this black dust where I'm able to collect from the fuel filter, and this is a lot, really a lot. And this is what of those remains from the fuel when we refill the petrol from the petrol station. And of course some of it belongs to the damaged float where it rub and scratch against the steel washer over a certain period of time, and all of this is accumulated inside the fuel filter for the past 3 years. Okay, and this is why it is so important to follow the maintenance schedule and to change the fuel filter periodically to avoid getting clogged. This is the result. Okay, and the last I would like to show this 4 pins connector. 2 wires is connected to the fuel pump and 2 wires is connected to the float sensor. Yesterday I used to connect these 2 pins located here above, okay, to supply current to the fuel pump. The positive terminal wire is labeled with red color with black stripe, connected to here inside, and the negative terminal is labeled with black color with yellow stripe. Okay, this is all about this fuel pump unit, and I shall prepare to install back the fuel pump onto the fuel tank. Yesterday night, I've gone to the petrol station to fill in 1.5 liters of fuel inside the fuel tank, and I put it here overnight to observe if there is any fuel leaks. And I'm quite relieved there is no sign of any leakage. Let's see below the fuel tank. Yes, and it's still looking good. And I've reached the final moment to assemble back everything in one piece. Precaution need to be taken not to over tight the screw underneath the fuel tank, because I worry it might crack the fuel tank and causing some fuel leaks. Okay, I've just gone to the petrol station to fill up some amount of the fuel inside the fuel tank, and the fuel gauge has resumed its normal operation. Yes! Yes! So, mission accomplished! And I hope you all did really enjoy watching this video, and please do me a favor by clicking on the like button, and if you have anything to say, please feel free to leave down in the comment section below. Till then, thanks for watching and ride safely.